Hi, welcome back to environmental chemistry. We're going to talk about the last two parts of the SL material. We're going to start with soil, and soil is where plants get all of their macroscopic nutrients. We're talking about where they get their phosphorus, their nitrogen, their metal ions that they need for building all the macromolecules that they need. All right, they get that normally from the topsoil, which is the nutrient-rich organic layer of soil that contains humus. It contains all of the materials from the decomposition of other organic matter, and it's the most important factor in the quality and the quality of the plant life, let's say. And so one of the things that we are worried about is the fact that we are experiencing, the world is experiencing soil degradation, which is a decrease in the quality of the soil due to the direct or indirect human activity. All right. So when soil is degraded, it cannot carry as many life forms or as many individual plants per square area. All right, for a unit of area. And so some of the different forms of soil degradation. There are three main soil degradation types: salinization, nutrient depletion, and soil pollution. So let's talk about those directly. Salinization happens because if you continuously irrigate an area in order to, bring water to the plants, well, as the water evaporates, it leaves behind the residual salts that are dissolved in the water, and that is going to cause a formation of salt crystals and crust over the topsoil. That is mostly prevalent in areas that really need significant amounts of water. So you need to continue irrigating, so like desertic areas or areas, for example, here in California, where we actually, towards the Central Valley, where there is actually a need for much more water to be brought in. The concentration of salt is actually problematic because not only can it be toxic, but it hinders the ability of of roots to absorb water from the system. Why is this so? The reason why it does that is because water passes into the roots by osmosis. If the concentration of the solution inside of the roots is greater than the outside, the water moves into the root. If the soil is very salty, the concentration will be actually greater outside in the soil than in the root, and water will travel from the root into the soil, dehydrating the plant. All right, so this is one of the reasons for that. So how do we fix this? Well, the idea is actually to flood the area, not just irrigate carefully, but actually to flood the area significantly, so the salt is redissolved in the water and it washes away into the waterways. Now the problem is, of course, that this can cause salinization of the waterways, but it's a very long-term process, so it's not ideal. The reality is drip irrigation is a much better form of doing it. Instead of having canals, if you actually have little irrigation hoses around where the plants are going to be growing, and we drip directly there, we can conserve water and actually minimize the effect of salinization. A second process that we can have, a second problem with soil degradation, is the idea of nutrient depletion. When we harvest crops, we are actually interrupting the cycle of actually plants taking nutrients, plant growing, the plant decaying, and returning the nutrients back into the soil. So we are capturing the nutrients and taking them away from the soil. So how can we do this? How can we improve the quality or cause this? Well, one of the things that we used to do in antiquity, and actually until very recently, when we decided to become lazy and have monocultures, was to actually have crop rotation. We would change the type of crops that we would grow in the different areas of a farm, and that way if the plant would be taking out a lot of nitrates from the soil, we would then plant a nitrifying crop the next time to replenish the nitrate and take some other type of nutrient. Well, what are we doing currently? We use a lot of fertilizers, artificial fertilizers that can add nutrients, but the problem is that those fertilizers can be washed off into the waterways and cause eutrophication. So that is never a good thing. Another way that we actually can work with to avoid nutrient depletion is actually using more natural nutrients or fertilizers like manure, which are much more closely resemble what the soil itself has in it, and can be the bacteria can work on it to actually integrate that into the soil better. Finally, the last type of soil degradation that we have is soil pollution, and that's because of the use of fertilizers and pesticides, insecticides, fungicides that can actually damage the quality, the chemicals that are in the topsoil. In addition, if you are near mining areas or areas where there is improper disposal of waste materials, toxic leaching that is coming out of the landfills, etc., those things can damage the topsoil and actually introduce toxic materials. In addition, if you have acid rain, as we discussed earlier, we're going to leach or solubilize aluminum ion, which is very toxic for plants. So any of those things can cause soil pollution. How do we fix this? Well, we minimize the use of fertilizers. We have to really be aware of we reduce acid pollution. We can lime the soil to reduce the acidity. And if you're like in an area where there's mining, well, we have to really make a bigger and better effort at containing those metals that are being released into the environment through the waterways. But it is actually a big problem. All right, so those are the three main types of soil degradation that you need to be able to know and discuss. Now, SOM, or soil organic matter, is a term for all of the organic material. We're talking about polysaccharides, proteins, sugars, amino acids, detritus from plants and animals decaying, whether it's leaves, twigs, or any of the other part of the biomass that is contained in the topsoil, or normally called humus. Those are the materials that the plants are going to use to take most of these nutrients that they need. All right, and SOM, the organic matter in the soil, has two important functions. Biologically, the most important function that it has is the source of phosphorus, nitrogen, and sulfur nutrients for the plants, and that's actually what the plant's going to need for building its proteins and building its more complex structures. All right. In addition, and we'll talk about this in higher level, it helps with the ion exchange capacity of the soil. This means that the soil contains, for example, metals, all right, like calcium ion, magnesium ion, potassium ion, which are important for the plant, and they can be exchanged in the plant, and the plant will give off H plus and take up these metallic ions, and that allows it to take these nutrients to build the other proteins and enzymes and that it needs, including chlorophyll. All right. Now, the organic acids that it contains, the humic acids that the soil organic matter contains, are the ones that help also trap those metals and make them soluble, and that's we're going to be able to establish some equilibrium in which ions can be exchanged from one direction into the other. So again, the hydrogen, can we, okay, no sneeze. The ions, the metal can be exchanged into the plant, and H plus comes back out. All right. In addition, it also keeps the pH relatively constant for the plant, so that's also going to be important for the reactions that the plant needs to make. Physically, SOM has a very, very important role in actually making the soil less dense, allows it to be more aerated. It actually helps with water control when it absorbs more water when it's dry, and it actually allows for water to drain more easily when it's saturated, so the water can continue to filter out, and so we don't either have a desiccation of the plant or too much stagnant water, which would rot the roots. So actually it's very good. In addition, because it actually has more air, and it allows the soil to be cooler in the summer, but the trapped air and the dark color of the soil will trap some more of the heat in the summer, in the winter, and so keep the roots from freezing too much. So actually it does help that as well. If we culture too much an area of soil, we till it too much, this will cause the breaking up of the larger parts of the SOM, and they can actually be broken down and eroded away through the air and water and be lost. Again, how do we regain some of the SOM? It's SOM actually, the soil organic matter is actually very, very slow to regenerate, but we can add manure and fertilizers and compost that is actually very similar in structure to actually regain some of that SOM that has been lost, but it actually does take a number of years for this to become better. All right. Some of the other soil pollutants that we see are things like leftovers of hydrocarbons, like polyaromatic hydrocarbons. We have VOCs, the volatile organic compounds, PCB from industrial waste, agricultural chemicals like organic phosphates and organotin compounds that are used for pesticides, etc., etc. And all of those can actually enter the soil and also cause some of that soil degradation, which we were talking about, the idea of soil pollution. All right, but these are some of the ones that have organic components in them. And that will be the end of the soil unit. So I want us to move on to now talking about, I think I clicked on the wrong page. There we go. On to waste. And we're going to look at waste in terms of solid waste. And there are three main methods of dealing with waste. And actually, if you remember, I've also given you a table in which you can actually look at some of the benefits, pros and cons to the methods of waste disposal, solid waste disposal, and recycling. Common ones. Landfill is one of the most common ones that we see. Is normally we're going to take the waste, put it into a pit or a natural valley or an unused quarry, and we're going to bury it so it is isolated from the air. This will actually cause the decomposition to be much slower and to be normally anaerobic. All right, so that can cause methane gas to be produced. So we have to be checking for the production of methane gas, because that could be dangerous. You could cause fires. It could cause explosions. The other problem with that is, of course, that rainwater is going to come in, and it can leach out some of the toxic materials in there. So we normally line the bottom part of a landfill with some type of impermeable clay, or actually literally sometimes some huge bags, like a tarp made out of plastic or some other impermeable material, to keep the toxic materials from reaching into the groundwater or any of the other soil. All right. Another type of waste disposal method, which is very, very cheap, is open dumping. We basically just throw the trash into some off a hill or something like that, and it's open, or it can be even just in a flat area, and it's left uncovered for aerobic decomposition. Now, while this may decompose faster, it actually tends to promote disease, because you have an increase in rodents and insects, and it can also cause water pollution. So this is not an ideal method, but it is very, very cheap. Ocean dumping is almost as cheap. You take a barge, you fill it with trash, and you dump it into the ocean, hopefully in an area where there is a trench in the ocean, so it does not interfere with navigation. But of course, this is very, very polluting to the ocean, because all of the toxic materials then dissolve and leach out into the ocean water, and not only bad for marine mammals, but also they get incorporated through biomagnification or bioaccumulation into the fish that we may eventually eat. Another type of way of dealing with Waste is incineration. All right, if we burn waste at very, very high temperatures, most of it will actually convert into carbon dioxide and water, leaving very small amounts of ashes behind, which can then be put into a landfill and take a lot less volume and therefore be much more cost efficient. Now, because most of it is organic materials, it will combust well, so you can actually use the organic material, the trash itself, to help be part of the fuel, or to reduce the cost of fuel for actually burning the materials. But you need to be very careful to have it at high enough temperatures, otherwise you will form some dioxins, which we talked about are very, very toxic. In addition, because you're releasing a lot of carbon dioxide, this has greenhouse gas effect, and also increases acid rain, because you're also going to, some of the other materials that are there are going to be containing nitrogen or sulfur, and therefore you're going to increase the nitrogen oxides and sulfur oxides being released into the atmosphere. So the best idea is to do recycling, which is to recondition the material for reuse, for use in new products. Better than recycling still is to reuse, but we're still trying to move in that direction. Recycling is the most costliest of the ways of dealing with waste, because both the cost of energy and the number of man hours that need to be spent in order to do recycling. So recycling is good because it reduces the use of raw materials. It normally tends to reduce energy cost overall. Instead of using new materials, it takes a little bit less energy for most processes to use recycled materials. It reduces the amount of pollutants that are being put out into the environment, and it reduces the amount for the need for landfill space. All right. Of those materials that can be recycled easily, metal, glass, paper, and plastics are the most common. Metal, paper, and plastic tend to be degraded in the process, and therefore, when you are recycling them, you really tend to use them for lesser methods. But glass instead does not get degraded at all in the process. So glass is one of the substances that can be recycled over and over and over again, being done, and still get excellent material. In addition, recycled glass is made in a much cheaper fashion. It takes less energy than producing it from fresh silica or sandstone or whatever other chemicals we make it. All right, so that's the basic idea on recycling. Finally, we get to the last bit of the material for today, and it's nuclear waste. There are two main types of nuclear waste that need to be addressed: low-level nuclear waste, or low-level radioactive waste, and high-level radioactive waste. That has to do with the activity, the amount of emissions that they produce, and the half-life. Activity, if it basically is emitting a significant number of radioactive particles per unit of time, and the half-life is the time that it takes for half of the material to decay. And every time it will take half of the material away. So it's not like it just two half-lives and you're done. The first half-life you go from 100% to 50, second half-life you go from 50 to 25, etc., etc. All right, low-level waste tends to be from research labs and from hospitals. We're talking about anything that is used for radioactive labeling in a lab, or for radiotherapy, for treatments of cancer, anything like this. So this is normally low activity that does not emit high amounts of radiation, and it has a relatively short half-life, a matter of days, weeks, or even perhaps a year or so. Normally what you do is you take that waste, you wrap it up, you put it into cooling ponds that will absorb the heat being generated or being given off by those radioactive emissions. Once the level of radioactivity has been deemed reasonable, normally about 7 half-lives, then we can take that material and dispose it into landfills normally. All right. High-level waste tends to come from nuclear reactors, the spent fuel rods, and from military applications. Of course, we're talking about the creation of military weapons, but also depleted uranium shells, etc., etc. They have to have a very high activity. They do emit a lot of radiation. They're dangerous in that sense, the amount of energy that is being emitted, and they have very long half-lives, sometimes half-lives that are in the million or billions of years. All right, and so what do we do? First of all, you actually cool for example, if we're talking about a nuclear reactor rods, we cool the fuel rods into water pools that have neutron absorbers, so in order to avoid any chain reactions from taking place. Then we encase that in ceramic or glass, and the process called vitrification. All right, that is put into metal barrels, and then those are buried deep into geologically stable mines or caves. For example, in Utah and in Montana, we have certain areas in the U.S. where we do this, and we hope that they will be away from groundwater, and they will be remain there for multiple millions of years. Of course, this is just wishful thinking from our side, and the best thing that can happen is for us not to use this high-level waste, but that is something to happen in the future. All right, that is the end of environmental chemistry. Thank you so much.